When installing a series of receptacles in a shop area for electrical tools, it's essential to understand the ground fault circuit interrupter, or GFCI protection requirements. The primary goal of GFCI protection is to prevent electrical shock. GFCIs work by monitoring the current flowing into and out of a circuit. If there's an imbalance, indicating that current is leaking to ground, the GFCI trips the circuit, cutting off power almost instantly. This rapid response can prevent serious injury or death. The National Electrical Code, or NEC, mandates GFCI protection in specific locations where there is a higher risk of electrical shock, such as bathrooms, kitchens, garages, and outdoor areas. The specific requirements can be found in NEC Section 210.8. In a shop environment where electrical tools are frequently used, GFCI protection is crucial. Tools can develop insulation faults over time, and the presence of moisture or conductive materials can increase the risk of electrical shock. To address your question directly regarding installing 7 receptacles with GFCI protection on a dedicated circuit breaker, all 7 receptacles must indeed have GFCI protection. There are 2 primary methods to achieve this. Firstly, you can install a GFCI receptacle as the first receptacle on the circuit, and then wire the remaining 6 receptacles to the load side of the GFCI receptacle. This approach provides GFCI protection to all downstream receptacles. However, it's important to note that if the GFCI receptacle trips, all 7 receptacles will lose power. Secondly, you can install a GFCI circuit breaker in the electrical panel. This circuit breaker provides GFCI protection for the entire circuit, including all 7 receptacles. If a ground fault occurs at any of the receptacles, the GFCI circuit breaker will trip, disconnecting power to the entire circuit. Using a GFCI circuit breaker simplifies the wiring at each receptacle location, as you only need to connect the standard circuit wiring to each receptacle. In either case, using a dedicated circuit is highly recommended. A dedicated circuit means that the circuit breaker only serves these 7 receptacles and no other loads. This is important for several reasons. Firstly, it ensures that the circuit has sufficient capacity to handle the combined load of the electrical tools that may be used simultaneously. Secondly, it reduces the risk of nuisance tripping of the GFCI due to other loads on the circuit, causing voltage fluctuations or introducing noise. Thirdly, it makes troubleshooting easier, as any issues in the circuit are isolated to the 7 receptacles. When installing the receptacles, it's crucial to follow all applicable electrical codes and regulations. Ensure that the wiring is properly sized for the circuit breaker rating, typically 15 amps or 20 amps for standard receptacle circuit. Use the appropriate wire gauge as specified by the NEC Table 310.15b16 based on the ampacity of the conductors and the temperature rating of the terminals. Securely connect the wires to the receptacles, ensuring that the ground wire is properly connected to the grounding terminal. Use appropriate wiring methods, such as conduit or cable, to protect the wiring from physical damage. Test the GFCI protection after installation to verify that it is functioning correctly. Use a GFCI tester to simulate the ground fault and confirm that the GFCI trips within the specified time. If the GFCI does not trip, check the wiring connections and the GFCI device itself. Regular testing of GFCI protection is recommended to ensure continued safety. It's good practice to test GFCIs monthly or at least semi-annually. In addition to GFCI protection, consider other safety measures in the shop area. Use properly grounded tools and equipment. Inspect tools regularly for damage or wear. Avoid using electrical tools in wet or damp conditions. Use extension cords that are rated for the intended use and in good condition. Keep the work area clean and free of clutter. Store flammable materials away from electrical equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. It is also important to understand the differences between GFCI protection and standard overcurrent protection. A standard circuit breaker or fuse provides overcurrent protection, which protects against short circuits and overloads. Overcurrent protection devices are designed to trip when the current exceeds the rated capacity of the circuit, preventing damage to the wiring and equipment. However, overcurrent protection does not protect against ground faults. A ground fault can occur even when the current is below the circuit's rated capacity, but it still poses a significant risk of electrical shock. GFCI protection, on the other hand, is specifically designed to detect and interrupt ground faults. GFCIs are much more sensitive to current imbalances than standard circuit breakers, and they can trip at very low current levels, typically around 5 mA. This sensitivity is what makes GFCIs so effective at preventing electrical shock. Another important consideration is the proper selection of GFCI devices. GFCIs are available in several types, including receptacles, circuit breakers, and portable units. Choose the type of GFCI that is most appropriate for the specific application. For example, GFCI receptacles are suitable for protecting individual locations, while GFCI circuit breakers are suitable for protecting entire circuits. Portable GFCI units are useful for temporary applications or for protecting equipment that is used in multiple locations. When selecting a GFCI device, make sure it is listed by a recognized testing laboratory such as Underwriters Laboratories or all. This listing indicates that the device has been tested and meets applicable safety standards. Also, ensure that the GFCI device is rated for the voltage and current of the circuit. It's also important to consider the potential for nuisance tripping of GFCIs. Nuisance tripping can occur when there is a small amount of leakage current in the circuit, even if there is no actual ground fault. This leakage current can be caused by various factors, such as capacitive coupling in the wiring or the use of certain types of electronic equipment. To minimize the risk of nuisance tripping, use high-quality wiring and components. Avoid running wiring in close proximity to other electrical circuits, and use equipment that is designed to minimize leakage current. If nuisance tripping is a persistent problem, consider using a GFCI with a higher trip threshold, but only if it is still within the limits of the applicable electrical codes. Furthermore, it is essential to understand the specific requirements of the National Electrical Code, or NEC, regarding GFCI protection. The NEC is a set of standards for the safe installation of electrical wiring and equipment. It is widely adopted throughout the United States and is updated every 3 years. The NEC specifies the locations where GFCI protection is required, as well as the types of GFCI devices that are permitted. Compliance with the NEC is essential for ensuring the safety of electrical installations. In addition to the NEC, local electrical codes may also have specific requirements for GFCI protection. These local codes may be more stringent than the NEC, and it is important to comply with all applicable codes and regulations. Contact the local building department or electrical inspector for information on local code requirements. When planning the installation of GFCI protection in a shop area, consider the layout of the shop and the location of electrical equipment. Place GFCI receptacles in convenient locations where they are easily accessible. Avoid placing receptacles in areas where they are likely to be exposed to moisture or physical damage. If necessary, use weatherproof receptacles and covers in damp or wet locations. Also, consider the potential for future expansion or changes in the shop layout. Install additional receptacles and circuits as needed to accommodate future electrical needs. In summary, providing GFCI protection for all 7 receptacles in the shop area on the same dedicated circuit breaker is essential for safety. You can achieve this by using either a GFCI receptacle as the first receptacle on the circuit or a GFCI circuit breaker in the electrical panel. A dedicated circuit is highly recommended to ensure sufficient capacity and reduce the risk of nuisance tripping. Always follow all applicable electrical codes and regulations, and test the GFCI protection after installation to verify that it is functioning correctly. Remember that GFCI protection is not a substitute for other safety measures. Use properly grounded tools and equipment, inspect tools regularly for damage or wear, and avoid using electrical tools in wet or damp conditions. By following these guidelines, you can create a safe and efficient shop environment for using electrical tools. Finally, remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are unsure about any aspect of the installation. A qualified electrician can ensure that the installation is done safely and in accordance with all applicable codes and regulations. They can also provide valuable advice on the best way to protect yourself and your equipment from electrical hazards. Always prioritize safety when working with electricity, and never take risks that could lead to injury or property damage. Electrical safety is everyone's responsibility. By understanding the principles of GFCI protection and following safe electrical practices, you can create a safe and productive shop environment. Remember to regularly inspect and maintain electrical equipment and wiring to ensure that they are in good working condition. Address any electrical problems promptly and seek professional assistance when needed. By taking these precautions, you can minimize the risk of electrical accidents and ensure the safety of yourself and others in the shop area.